I'll kick off the first question and we can get going. So Pierre, we wrote this report. We just published it. It's right now. It's live on the Blockware website. It might be on the Riot website as well. Why did we write this report, and what is it all about?
Yeah, so I think that there's been ongoing conversations about whether Bitcoin is quote unquote secure long term. Uh, when we learn about Bitcoin's sound monetary policy, that there's only going to be 21 million Bitcoin with the halvings, it naturally raises the question of what happens after all the Bitcoin are mined. And if the miners are the ones that are ordering transactions, then if and they're getting paid from new issuance of Bitcoin, then doesn't it follow that if there is no new issuance of Bitcoin, then the system kind of falls apart? So we wanted to get into what is going on with transaction fees, because that is what Satoshi pointed to in his white paper of, hey, look, after all the Bitcoin have been mined, the miners will be paid by transaction fees. So our report goes into how transaction fees work, their historical trends, right? They've been very volatile over the past. What has driven that volatility, namely scaling and congestion, as well as looking more speculatively at, okay, well, would these transaction fees be helpful if there was censorship on the network? And the censorship conversation really actually took off very recently, again, because of Tornado Cash on the Ethereum network, and that being put on OFAC lists. So, um, the report goes into hypothetically what would happen if miners decided to censor a transaction, showing that because Bitcoin mining or hashing or whatever we want to call it, because that is permissionless and anybody can do it, and because the fee market is a dynamic market that is set in the mempool, that actually we don't really have any big reasons to be concerned about censorship long term, even if all the Bitcoin have been mined. So I think that's the TLDR, but I'm sure that you could add to that.
Yeah, no, I think that was a great synopsis, and I think we can just kind of dive into the report. I know one of the first sections, and there's kind of basic, but it's kind of explaining, how Bitcoin transaction fees work, and just generally, like, why does Bitcoin have a block size limit? Can you explain that? Pierre,
Oh,
you're on mute.
sorry,
Yeah.
sorry. Yeah, I was on mute. Um, and I don't want to be the only one talking today, so Joe, you're going to have to answer some of these questions as well. But in 2010, before he left the project, Satoshi put in place a block size limit. Um, First and foremost, to prevent denial of service attacks on Bitcoin nodes. So you can think of this like if a miner proposed a block that was 1 gigabyte, then as a node is downloading this, it would actually, if it doesn't have enough memory or enough processing power or enough bandwidth, it would actually choke on it, and it would, potentially cause the node to go down. And if a denial of service attack, so one of the trade-offs that Bitcoin has is that it's an open network. And so when you're on the open internet, you have adversaries who are constantly trying to disrupt your network. If Bitcoin was a proprietary closed network that was more of like on an intranet or on a VPN, like Visa is, then there would not be very much of a concern about denial of service attacks, because you can control who is on the network and who is not, and you can help prevent resource exhaustion problems this way. So Bitcoin being open network, open source, you have to have mechanisms for counteracting or mitigating denial of service attacks. One of those is the block size limit. Um, Bigger picture, the block size limit also puts a ceiling on the growth of Bitcoin's blockchain. This is important for helping lower the cost of running a Bitcoin node long term. So, Bitcoin's decentralization hinges on the low cost of running a Bitcoin node because a Bitcoin node is what allows you to actually verify and implement the rules of the network yourself so that you're not having to rely on a trusted third party. That's the entire premise of the Bitcoin system, is that a Bitcoin node is what is peer to peer. It's what allows you to not use an intermediary. Um, Now, if using a Bitcoin node was too expensive, you could think of, kind of the absurd argument of, oh, well, we have 1 terabyte blocks. And so now only Google and Amazon and big tech can run Bitcoin nodes. Well, we've seen what happens when only big tech can do something, right? They engage in anti competitive behavior and all sorts of regulatory capture and political shenanigans. So we want to stay away from having gatekeepers like that, and having Bitcoin degenerate into a centralized system. So keeping the cost of running a Bitcoin node low is how we keep Bitcoin decentralized, and that is one of the major benefits of the block size limit. Now, the drawback of the block size limit is that it creates scarcity for block space, that is, for transactional throughput, meaning that if there's a lot of demand for transactions on the Bitcoin network, the supply, it can only increase up to a certain point. Now, when Satoshi left, he put in place a 1 megabyte block size limit. In 2017, the Bitcoin developers and community and node operators, they activated SegWit, which actually changed Bitcoin's block size limit functionality to be a block weight limit of 4 million weight units. I won't get into the technicalities of what weight units are, but suffice it to say, it's now roughly 2 megabytes of a block size limit. And that really is going to depend on how many of those transactions are using SegWit and other factors as well. But um, the, so when there's a lot of demand for transactions, for transactional throughput on Bitcoin, that does cause there to be a backlog of transactions waiting to get into the next block. um, this backlog is in the mempool. So the mempool is a queue of transactions waiting to get into the next block. It's rank ordered by their fee rate. And so when there's a lot of congestion, what we see is that transactors compete against each other to try to get into the next block by paying a higher transaction fee rate. And so historically, for example, in December of 2017, we saw transaction fee rates dramatically increase. And we saw a little bit of an increase in 2020 with that bull market as well, 2021, but not nearly as much as what we saw in 2017. So the block size limit, the block weight limit, hugely important for decentralization, but also problematic for adoption and growth when there's a lot of people who want to use the Bitcoin network.
Yeah, that was great. And I think the block size limit leads into the idea of Bitcoin's scaling cycle. So, and you kind of touched on this, but I'll just reiterate through a lot of what you said and kind of expand on it. You know, Bitcoin's second and third layer scaling solutions aren't necessarily, perfectly timed to coincide with new ways of adoption. And we've seen this, right? And you just mentioned we had transitory fee spikes that occurred in 2013, 2017, and a bit in 2020 as well. And high fees actually bring pressure to users on the network to more efficiently use block space by adopting, these new scaling technologies. And so these scaling technologies are basically cost saving measures that enable an increase in the total throughput for Bitcoin, for the entire Bitcoin network. But like you said, it retains that small block size, which decreases or keeps the cost of running a Bitcoin full node low, which basically secures Bitcoin's decentralization. So Bitcoin's scaling cycle is this idea that as adoption increases, fees increase as more people and more entities are trying to grab their UTXOs on the blockchain. They're trying to hold their own private keys. They're trying to retain ownership of the Bitcoin without any trusted third party. So fees increase, but when fees increase, the demand for cheaper settlement increases. That leads to the developing and implementation of various second and third layer scaling technologies. This can be SegWit, it can be exchanges batching transactions, it can be Lightning, Liquid, new ones like Fedimint. And once these scaling technologies are developed and implemented, and we've seen this with exchanges, batching transactions. Pierre, I know you worked on Lightning at Kraken. SegWit has been implemented more and more. When these scaling technologies get implemented, Bitcoin more effectively or more efficiently scales, and then fees end up decreasing, and then we have that next wave of adoption, and fees end up increasing. So this is kind of the cycle that has played out repeatedly, and I think it's reasonable to expect the cycle to play out for the foreseeable future as well.
That's right. And it's hard to attribute, for example, the 2021, let's put it this way. Bitcoin transaction fees in 2017, it went up to like, for a typical Bitcoin transaction, you can be paying like $35, $50 for a transaction. Afterwards, after that bull market into the 2018 bear market, it got down to like a nickel per transaction. Now, despite the Bitcoin exchange rate going 3 times higher than it did in 2017, that is $60,000 versus $20,000, transaction fees in dollar terms did not triple between 2017 and 2021. So there's clearly gains in efficiency. And the other thing I would point out is that people will say, "Oh, well, it's because people used Bitcoin less," and the reality is that Bitcoin over the past year has had more usage than over any other 12-month period. So the low transaction fees on Bitcoin of a nickel have coincided with historically unprecedented usage of Bitcoin, where there have been approximately $50 trillion worth of Bitcoin that have settled on the network at extraordinarily low transaction fee rates. And so if you look at it as a percentage, right, of bips of the value of transactions, it is just astonishingly low, and I think speaks to the fact that the Bitcoin network is secure even when Bitcoin transaction fees are low. And it's not because of the subsidy or anything like that. I really think it's because of the game theory. That is, that if somebody were to try to censor a Bitcoin transaction, the transactor who is being censored would just increase their transaction fee that they're paying, and they would uncensor themselves. And so there's just not a strong incentive for an attacker to perform an attack that he knows the defense will be effective. They might as well just not attack. And so then you get to a default, game theoretical outcome of, well, there's low transaction fees and no censorship.
Yeah, definitely. That makes a lot of sense. And I think going further on the idea of just Bitcoin adoption in general, and trying to increase throughput, Blockware actually did some estimates using Glassnode data prior to this report that kind of showed that there are about 32 million entities that currently store wealth on the Bitcoin blockchain. And pretty much all of these 32 million entities are currently just using Bitcoin as a store of value and not a payments technology. So in the report, we talked about like what happens when there are 7 billion entities using Bitcoin as a store of value. Like that's a 218x increase in entities competing for the exact same amount of block space, right? And like you said, they're going to be using second and third layer scaling solutions, but Bitcoin's base layer provides the maximum level of certainty, or at least amount of uncertainty, to settle transactions and provide lasting savings. But that's just kind of the beginning of what Bitcoin could potentially be. If Bitcoin users go from 1 to 5 transactions per year to maybe 1 to 5 transactions per day, when they're using it more as a medium of exchange or payments tool, and this could happen decades from now. Who knows the exact timing? But with 7 billion people using Bitcoin as a payments tool throughout the world, throughput would basically have to increase by almost 80,000x from where it is today. And again, like I mentioned, like a lot of this is probably going to be done on second and third layer scaling solutions like Lightning and Fedimint. Some scaling solutions we may not even have considered or thought of yet. But I think Bitcoin's going to continue to go through these fee cycles as people around the world continue adopting it. They continue to demand final settlement of Bitcoin, and throughput is just going to have to increase, and the scaling cycle will likely continue.
Yeah, that's right. And some of the scaling solutions we might not like. For example, exchanges or custodial wallets like that. The what will always kind of counteract or cause people to avoid centralized solutions is seeing their drawbacks, right? And we see Mt. Gox has been in this process of bankruptcy for so many years now, causing so many early adopters massive pain. That's, I think, every time that we have a scaling solution like that has trade offs, people will learn the hard way. And so I also think that even Lightning has trade offs, for example. Um, you cannot send large amounts of value over the Lightning network very easily. You would have to open Wumbo channels specifically to the destination you're going to. On top of that, Lightning transaction fees or routing fees, as they're called in their system, are based on how much value you are transferring, whereas on chain they're based on how much data you're consuming. And so there's always going to be fundamental trade-offs between the different scaling solutions, and I think that's why, even though we're going to see changes in the usage of on-chain transactions, we'll always see usage of on-chain transactions, and there will always be demand for on-chain transactions. In particular, for example, with cold storage, right? Currently you can't really do cold storage with Lightning. And if you look at Fedi or other solutions like that, they're focused on really the day-to-day payments application, and that is a fantastic area to focus on. But ultimately, on-chain transactions will always be needed. I think for cold storage and for long-term savings, as well as large payments of value.
Yeah, I certainly agree that the base layer of Bitcoin provides that maximum level of certainty compared to other second and third layer scaling solutions. But second and third layer scaling solutions will still be extremely useful. Um, uh, what are your thoughts on like the idea that? Go ahead, Pierre.
Oh yeah, I just wanted to also mention that there are base layer scaling improvements as well. So one in particular I'd point to is with Taproot and multisig. So the old version of multisig, when you put a lot more data on chain, because basically you put the same number of signatures as there is in the multisig as on chain data. Whereas in the future, multisig will actually just have one signature on chain, and so that way it'll still have the same cryptographic properties, but it will be a lot less data on chain. And I think that's the kind of scaling that is really exciting. Is rather than just increasing the block size limit and kind of, I would question whether that's even scaling per se, because you're not actually increasing efficiency. But with Taproot, you certainly are increasing efficiency. And then there's other scaling improvements, like on the roadmap of cross signature aggregation and or cross input signature aggregation, that would allow us to again put more transactional throughput using less data on the base layer.
Definitely. Um, we've touched on this a bit at the start, but I want to get your thoughts on why is this report about Bitcoin's settlement finality and not about Bitcoin's security?
Yeah, so security, I think should be really relevant to um, areas of either private key security, right, keeping your keys secure, or keeping your software secure. Focus on what for me, like a security improvement to Bitcoin was the block size limit, right? Preventing a denial of service attack is a security improvement. Furthermore, the security of the hash rate, right? So we want, for example, Stratum V2 is going to have encryption. So there are security improvements that we can do at the hash rate layer. Um, when people apply security to describe what I think is more precisely transaction finality, um, I think that they're trying to create a bit of a hysteria, right? That by using the word security, they think that they can increase the amount of panic involved with criticizing Bitcoin or pointing out, some uncertainties about its future. Um, so, security, I think, is a misnomer. Transaction finality is seems to me to be more precise about what the concern is here, which is basically being able to either censor transactions to prevent them from ever having finality, or undoing their finality, right, by engaging in deep reorgs. And so that is a much narrower set of concerns than security writ large. Um, and maybe it's less exciting than to talk about Bitcoin's security model or Bitcoin's security budget. Uh, but it improves the analysis because when people talk about security budget, they look at it as prospective. That in order to prevent future attacks, we have to have a certain level of security budget. And that's just not what the software engineering of the Bitcoin system is. The software engineering of the system is that in order to counteract, in order to defend against past or current attacks, then you have to increase your transaction fee. Not really a budget per se. It has to do with, are you being censored or not? And if you're not being censored, then there's no reason to be spending resources on something to mitigate something that's not happening, right? And then people get into like analogizing to the US military or something, right? Where, oh, well, we want to have a big defense budget as a deterrent to stop people from attacking. Um, and I think that that's a political point of view, and that's fine. But ultimately, Bitcoin is a software project, and so if you want to have a political point of view, then you'll have to persuade others that we need to update the software with your code. And I haven't really seen anybody propose code changes other than uh, increasing inflation, which to me is neither here nor there because, as Eric Voskuil and others have pointed out, um, increasing the subsidy does not actually increase transaction finality. What you need to be doing is increasing transaction fees. Um, so maybe somebody will propose some code of, oh, how do we increase transaction fees? One possibility is to lower the block size limit. That's what Luke Dasher has proposed. Um, but I think that we should not fix problems that don't exist. Bitcoin already has a lot of problems that we need to be directing thought and resources towards. We have not seen a concerted effort to double spend or to do deep reorgs on Bitcoin, despite more than a year of extremely low transaction fees and extremely material amounts of Bitcoin being transacted. So this is a problem, or this is a vague solution in search of a problem at this point.
Yeah, I fully agree there, and I think at the end of the day, miners have the ability to do one thing, and it's propose blocks that nodes who we set the consensus rules, verify, accept, and use to update the ledger. So, as you touched on, since miners cannot change key consensus rules, malicious miners can only censor specific transactions they do not want to include in their own blocks. They can get creative with this, but all attacks that miners can do stem from only being able to censor transactions in the longest proof of work chain. So maybe I can get into the three example attacks we listed into the report. The first one was just the ability to double spend your own coins. And this would be an economic attack. So the miner or the attacker would spend BTC to a receiver's address, and at the same time begin mining a chain with that original transaction sent back to themselves. So the receiver would initially see the transaction confirm until the attacker later releases the longer chain without the original transaction, and the receiver would no longer have the BTC, and the attacker keeps the original BTC. So that's one example of 51% attack. Second one would be basically allowing nobody to transact by mining empty blocks. This would be more of a non-economic attack, and the attacker would just continuously broadcast empty blocks to prevent any users from transacting. And since the attacker would have more than 50% of all the hash power, honest miners would never be able to mine a block that gets built on, as the attacker would be able to reorg out non-empty blocks and that the other miners might attempt to produce, and the attacker would simply just keep building empty blocks on his own chain. Again, but this is the attacker is still just building, doing, there's no economic reward for this per se, and he's just spending energy and resources to do this endless attack, because once he stops the attack, honest miners can just continue operating normally. The third attack that you touched on a bit was just deep reorgs. So the attacker would simply silently be mining a chain of empty blocks. The attacker would wait for a large number of blocks, honest blocks, to be mined with transactions from miners that are just collecting fees. And later, the attacker would broadcast their empty, longer chain of blocks that are still valid but just contain no transactions. Effectively, all nodes would see that the transactions that they thought previously confirmed actually did never not confirmed. And again, I think this is another non-economic attack, because the attacker would burn resources for nothing in return. But at the end of the day, all of these transactions could go back into the mempool. Everyone would be raising their fees to get in the actual next block. And whenever there was enough fees or enough honest miners to come back on the network, this attack would be mitigated.
Yeah, and I think that the mempool is such a critical piece of the puzzle, and it so often gets overlooked that there is a very competitive market that is feeding transactions into the block proposing. And so looking at miners in a vacuum would really lead you to the wrong conclusions if you don't include this dynamic fee market that is adjacent to the miners, and that is really maintained by the Bitcoin nodes. So the mempool has rules, right? It has validation rules of its own, and so it's not as gameable as folks think. Yeah, I'll leave it there. But the other point that I would make here with regards to these attacks, one, they might not necessarily be intentional or malicious attacks. They could also just be accidents or bugs in the software that would cause this problem. So It's not purely about, okay, is somebody bad at going to do something. It could also just be, are miners, do they have unreliable software because of a bug in some firmware or some pool implementation. The other is that, well, also there are researchers that look at it purely through the lens of what is the cost of acquiring the ASICs or acquiring the mining hardware. And I think that this kind of cost approach is misguided because it's not reflective of the fact that an attacker could actually be engaging in hacking, right? So they could be hacking into existing mining hardware through some kind of backdoor or zero-day exploit or social engineering, any kind of way where they could actually take over hash rate at a cost of basically zero. So I don't buy the modeling that looks at, oh, well, here's the cost of buying the A6, and therefore here are the conclusions. That's not the only way that somebody could get hash rate. Furthermore, if it's government, they can just seize the hash rate. So there's not really any kind of cost there, other than obviously the rule of law costs of seizing somebody else's property. Um, Now, the but I think that the mempool model that we put forward really sidesteps all those issues, because then if we're talking about the opportunity cost, those apply regardless of how the hash rate was obtained, and the cost of the hash rate becomes irrelevant. Now you're really just talking about the opportunity cost of not including the transactions.
I think that makes a lot of sense. And basically, like the idea is, Bitcoin's fee market is, kind of what makes it resilient against any sort of adversaries. I also think there's this kind of attack paradox when it comes to at least attacking Bitcoin from like a nation state level per se. And it's kind of the idea that, okay, is Bitcoin disrupting its monetary competitors in an unpopular way? Obviously, right now, the answer is definitely no. And as we've seen, governments have no interest in burning massive amounts of resources to destroy Bitcoin. But if it was, and I honestly don't think it necessarily ever will, for example, there aren't many, U.S. politicians that actively want to ban Bitcoin. If anything, there's an increasing number of U.S. politicians that, are promoting Bitcoin and recognize that there's this subset of the population that is, has wealth in Bitcoin and is, going to vote for whoever promotes the most Bitcoin friendly policies. So I don't think at all that Bitcoin really disrupts the U.S. government or any government at all. I think in a way this is Bitcoin is just another asset, right? Bitcoin, like for the U.S. billionaires and Elon Musk or Jeff Bezos, they don't necessarily hold a large portion of their portfolio in cash. They hold real assets. They hold equity. They hold real estate. Maybe they hold Bitcoin. They Bitcoin is just another asset that people will hold. Dollars just kind of like an accounting and tool to borrow more dollars, right? Like people even the wealthiest people in the world, they might not actually just not hold dollars, they may owe a bunch of dollars. So everyone's kind of incentivized to see Bitcoin and equities and real estate go up in value. So I don't really think it's ever going to really disrupt uh, you know nation states to the extent that people might expect. But if it does, and it's unpopular, I think that by that time Bitcoin is worth trillions and trillions of dollars, and any attacker would be met with trillions in these market-based counterattacks from the fee market.
Yeah, I agree with that, and it's also just intellectually dishonest when people set up scenarios where the attacker has infinite resources and is omnipotent, but the defenders are utterly destitute and powerless, and then saying, "Ah, well, you see here in this particular scenario, Bitcoin fails." It's like, well, okay, but that's just because you set up the premise such that Bitcoin fails. The reality is that it's far more balanced than that. And the other challenge for the attacker is that they might not be the only attacker. So the moment that you have more than one attacker competing for hash rate, well, now you're back to decentralization and you're back to them competing against each other. If we look today, you know, three of the major mining Bitcoin hashing jurisdictions are the United States, Russia, and Iran. So these are three countries that, somebody might argue that Russia and Iran are aligned. I don't know how true or how strongly aligned they are. But in any case, there's certainly um, tremendous disagreement between the three of who should be getting sanctioned, who should be getting censored. And so imagining cooperation between them or that, they would not be at odds on how to run their attack on Bitcoin. It's science fiction to think that Russia and the U.S. would cooperate on attacking Bitcoin.
Definitely. I think we touched on a lot of great topics in this report, and if anyone actually wants to read the full report, definitely check it out. It's on my Twitter, on Pierre's Twitter. Pierre, if users and we've made it pretty clear that obviously right now, no one's really worried about a 51% attack, but people, theoretically might be worried about it in the future. So if in the future users are worried about a 51% attack or basically lack of settlement finality, what can they do, Pierre?
Yeah, so for one, you have to think about like the particular scenario. So it's if you are a user who is, let's say, an airline that is buying jumbo jets, $5 billion worth of jets from Boeing, and you are going to settle this using Bitcoin. Um, well, the delivery of those aircraft is going to take a very long time, right? Months, maybe years. So that's basically the time frame you have for settlement finality. Um, on the other hand, if you are buying your coffee at Starbucks, your time frame for settlement finality is seconds. So in the Starbucks example, you would use Lightning, and you might have opened that channel months ago or years ago, and so you get instant finality for your coffee, and you still have the same. It's backed by the transaction finality of Bitcoin so deeply that you don't have to worry about a reorg or things like that. So um, I think that there's the time element of how long you wait for your transaction to be buried behind hundreds of confirmations. The other one is just thinking about, okay, if somebody were to unmine my transaction, right? So take it out of a block, put it back in the mempool. Then you get into a race condition with increasing the fee rate. So if you want to get your transaction back into a block, do child pays for parent, do RBF perhaps, and that you can drag it back into a block and try to outbid the attacker. So all of these are rather hypothetical unless you look at other blockchains, right? So other blockchains have had double spending issues. It's not like their exchange rate went to zero and all the exchanges delisted them. What exchanges did instead was increase the number of confirmations that they asked for. And so by extending the time frame for transaction finality, you can get to levels of assurances that would make it too expensive for the attacker to really do a deep reorg.
Yeah, absolutely. I think, in an absolute worst case scenario, waiting a day, 144 confirmations, or a week, for final settlement without actually relying on any third party is, extremely valuable, right? Like today,
Yeah, well, and you're also, I mean, you're assuming you're not using Lightning, right? Because if you're using Lightning, you can still have instant finality. It's just the channel opening and closing would take a long time.
Yeah, absolutely. And today, even in comparison to Lightning or base layer, Visa and ACH, their finality is measured in weeks and months, and reversals are much easier than purchasing and running a majority of Bitcoin's hash rate.
Yeah, absolutely. And it's interesting to bring up the example of Visa and kind of the reversibility of payments there, where um, you know double spending or reversing transactions is a part of their business processes. It's like built into their system, and so when people talk about, oh, Bitcoin is going to fail because some people might be able to defraud others by reversing a payment, it's like, okay, well, you're making the argument here that Visa has failed, and I just don't buy it. It seems like they're doing rather well. I know that's not the outcome we want on Bitcoin, but I'm just pointing out that um, to say that, oh, if this is if double spending in Bitcoin, a small amount is a problem, then that is existential to Bitcoin. I don't buy that. Is it inconvenient? Is it annoying? Or should we try to find ways to mitigate it? Yes, and there are ways to mitigate it, right? Transaction fees and waiting.
Absolutely. I think we touched on just about everything, at least from a high level. Anything else you want to mention to the listeners?
Yeah, I mean, I think that, in the Ethereum culture, they talk about um, having issuance pay for security and, minimum viable issuance to, have security. And then on the transaction fee side, they've put in this fee burn so that, the fees are not going to either congestion pricing to the stakers or in kind of a censorship scenario to the stakers. So I think that the Ethereum folks are going in the diametric opposite direction of Bitcoin, um, and I don't quite understand how they're going to measure or try to correlate security with their issuance, because there really is no correlation between the two. Um, and I think that opens them up to a social engineering attack from stakers, of stakers saying, hey, look, we're getting double spent. Now, whether they are or not irrelevant, they can create a false flag. It's all pseudonymous. And then they can increase their staking yield and further dilute Ethereum. So I don't think that they're really, following any kind of rigorous research here. But they're more focused on how do we make it so that we can try to pump the value of ETH instead of thinking about transaction finality.
Definitely. And unfortunately, the value of ETH comparative to Bitcoin is not pumping right now. So we will see how that works out for them.
Well, yeah, arguably it did after EIP 1559, this fee burning mechanism, but it goes back to, why were Ethereum fees high? Well, they were high due to congestion. And so if the Ethereum researchers are successful at reducing congestion using layer two scaling, or with Arbitrum and whatnot, or using layer one scaling or sharding in the future, if they are successful, then transaction fees on Ethereum will, collapse as low as possible, just like they have on Bitcoin. And in which case, there's no fee burning going on, and so they don't have kind of the ultrasound money properties that they have been promoting, and the fee burning was very much a short term, performance enhancing drug that perhaps pumped their coin, for a few months, but it's not going to have any lasting results.
Yep, fair enough. Well, if anyone wants to check out the full report again, it's on our Twitter. It's on the blockwaresolutions.com website. Um, as long as, Pierre, if you got anything, final thoughts, otherwise I'll wrap it up.
Well, we've got 12 minutes to go, so let's get some audience questions here if anyone wants to come up on stage. Nope, nobody. Oh, okay, we got one. Yep.
Hey, can you guys hear me?
Yes.
Yes.
Hey, I just want to say first, thanks, Joe and Pierre, for putting out this report. I think this is a really important issue because I've found in having conversations with people that this is like the smart person's FUD. Like they kind of understand Bitcoin and how it works. And then they bring out, well, declining fee subsidy. Like, what are you going to do with that? It's a race to the bottom. So I was having a conversation with a really smart friend of mine who's an attorney, patent attorney, but he also does fintech work, and kind of, I thought, understood this area, and was telling me, don't focus on Bitcoin because, the fee subsidy is declining. It's going to go to zero. And, he also said the time between the halvings is decreasing. I was like, yeah, but the difficulty adjustment. So this is good to have to give to people and say, no, this is actually not as big of an issue as people are making it out to be. It's certainly at this point kind of a hypothetical issue, like Pierre was saying. So thanks, guys, for putting this out.
Yeah, no, appreciate the kind words. And yeah, like I said, we definitely agree that this is pretty much a hypothetical issue. Like right now, there's for either Bitcoin Cash or Bitcoin SV, the total block reward is currently less than transaction fees, the dollar amount on Bitcoin, and you can still trade these coins on exchanges. They simply require more confirmations. So it's an interesting point. It's very hypothetical, and we definitely see a lack of attacks even on other less superior chains.
Yeah, and I think some of what it is too is this almost foregone conclusion that people have that Bitcoin is not going to be, adoption is not going to be large enough, and that block space is not going to have a premium such that transaction fees can't can't provide the settlement finality, right? It's like, well, without the block subsidy, whose transaction fees are going to be nothing, and so nobody's going to want to use it. It won't be secure. But that's what I find to be kind of like this inverted logic.
Definitely. I see Eddie is requesting to come up. I'll let him come up as well. Eddie, do you have any questions?
Yes, hello. Thank you, guys, for the report and the space. So, one of the things that have always graded me is that people think about mining, and especially the Coinbase reward, has having to do with security. And it is not emphasized that it might not be about that at all. It is just the part of the design of Bitcoin that guarantees fair issuance of the initial coins, and that we are just in a very anomalous phase in the Bitcoin trajectory, because we are so close to the beginning that the subsidy, the new Bitcoin being created to every block, is very large. And I think that there are some people who say, well, but this is the only thing that we have seen that it works. And we would like this to continue to be like that, because it projects into the future well. And it just, I think that we don't even have to take that point of view seriously, because the point of view that this is the only thing that we have seen works cannot possibly apply to replace the monetary infrastructure of the world.
Yeah, I agree, and I also I disagree with their view that this is the only thing that we've seen that works, because we have seen the Bitcoin transaction fee market, go up and down, and so I think that we've seen a very wide range of conditions in the mempool, and we saw that they all worked. The other point I would make is that with regards to the subsidy, the purpose of having the subsidy inside of the block reward, or the mining reward, the hashing reward, is to prevent seigniorage. And so seniorage is when you're adding units to the ledger, right? You got to have some kind of monetary asset that you're putting onto the ledger. Um, and if you have a monopoly on who can add the token to the ledger, then they're going to earn a monopoly profit, right? Based on the difference between the value of the token and their cost of production. So having this process be a part of the competitive hash rate of the competitive, you know, decentralized, permissionless aspect of Bitcoin mining, that makes it so that there is no seigniorage because anybody can add Bitcoin to the ledger, and it's just you're right that it's a temporary thing because we only need to add units to the ledger once. There's not really an argument for why there needs to always be additional units on the ledger. Bitcoin has tremendous divisibility. One Bitcoin has 100 million Satoshis in it, or rather the reverse, really. If you look at the software engineering, 100 million Satoshis, can be looked at as one Bitcoin. So the argument for the subsidy or the purpose of the subsidy is purely about, okay, how do we add units to the ledger but not give somebody a privileged position in the monetary system where they can profit at the expense of other participants. What is I'll let it rest there.
Yeah, I think the block subsidy and just the initial distribution of Bitcoin is kind of like a fascinating topic. And even like creating the idea of being able to create money from scratch is interesting because I think, for something to become money, it needs to be both scarce but well distributed. But how do you go about distributing it? Well, like proof of work with a difficulty adjustment is, in my mind, the actual over time, the best way to initially distribute money. It's interesting to think about. It's hard to think of a better way to go about it. But yeah, I see we have 5 minutes left. I don't see anyone else requesting, but if you have a question and want to ask us, just hit request on the space and happy to answer for the last 5 minutes. Looks like we might not have too many more questions. We did record this space, so once we end it, I think you'll be able to watch it or listen to it on Twitter, and we're going to upload it to the Blockware Intelligence YouTube too. Any closing thoughts from anybody on stage?
Yeah, well, thank you, Joe, for writing this with me, and it was a lot of fun working on it together. Really happy with the way it turned out. I think that it certainly addresses the smart man's FUD, and hopefully it'll also prompt some responses, and we'll see additional work done in this area.
Yeah, absolutely. I think it's a super important topic to continue just researching and iterating on, and excited to see all the feedback from the community, and likewise enjoyed working on it with you, and excited to see what else we do together. All right, well, thanks everybody. I'll go ahead and end this space. Appreciate you guys coming out and listening.